Here are our objectives for today, Lesson 3.6. Solve polynomial inequalities, solve rational inequalities, and solve word problems that model both of these types of inequalities, both polynomial and rational. Okay? We're going to use the calculator a lot today to talk about these two types of inequalities because I think a graphical view of these is really helpful. Okay? If I give you a problem, let me move this out of the way real quick. If I give you a problem like x squared minus 7x plus 10 is greater than 0, I want us to have a visual representation of what that looks like. Look, I said 10 and then put 0. Great. So first of all I did was graph the equation for you. X squared minus 7x plus 10. Okay, let me zoom in a little bit so you can see it a little bit better. Okay, this is a graph of x squared minus 7x plus 10. Okay, now here's the thing about it. If I tell you that this is an inequality now, and I want everything that's greater than 0, isn't it everything that's above the x-axis? Isn't that greater than 0? So what we have to figure out is, well, what does that mean? What does that mean for our answer? Okay, so I'm going to graph this real quick. We know that this is crossing the axis at 2 and 5, isn't it? Because if we factored that, let me zoom back out a little bit, it would be x minus 2 and x minus 5. Set each one of those equal to 0, and I get plus 2 and positive 5, right? So it's like something like that, right? That's what it just looked like. Okay? So what I'm saying is this part doesn't really work in this part of the problem, right? So what kind of answer do I have? Well, my answer is then everything over here and everything over here, right? All that stuff is my answer. So I have to figure out how to write that as an answer. Well, we're talking about solving for x, so we're talking about our x values. So in a way, we're just basically talking about our domain, aren't we? Okay, so if I say everything less than 2, would that be proper? Would that be correct? X is less than 2. Is it equal to 2? It is, because it touches, except I'm saying everything greater than 0, so does it really touch? No, so it's just everything less than 2. Okay, if that said greater than or equal, then yes, this would be less than or equal to 2, right? Well, what's the other part over here then? Greater than 5. Okay, now we could write it like that because it's this or this. We'd have to have that in there right there, right? Would we want to write 2 is less than x is less than 5? No, that says the complete opposite. That's saying it's everything between the two. We're saying it's everything outside of the two. Okay? So that's how we would write it in inequality notation. How would we write it in interval notation? Parentheses on all of it. It is. We're doing this and this part. We'll talk about it in a minute. Okay. Yep. This means union, so it's and. It's this part and this part. The other part is the intersection. It's where they meet, where they cross. These don't meet anywhere or cross anywhere. So we just want to have the union. Okay? Does everybody understand that part? Because, I mean, that's it. That's all we have to do. Now, there's ways that if you want to look at my book, you can come look at the example in my book because it has you factoring this. We kind of did that when we were thinking about where the answer was, but they have you doing it all algebraically, solving it algebraically. Guys, we have a calculator at disposal. We might as well do it that way. Are you okay with that? Okay. So, let me give you this one. 4x squared is less than or equal to 1 minus 2x. Well, we probably want to get it to 0 on one side or the other. Okay? I like to have my x squared term positive. It makes a lot of things a lot easier, so I'm going to go ahead and move everything to the opposite side. Even though I'm moving more stuff, it keeps my x squared term positive. 4x squared minus 2x minus 1. Thank you. Is less than or equal to 0. Thank you for that. I appreciate it. Thanks. Jerk. Okay, so how do we solve this? Well, we could factor it, right? We could try AC and see if we could factor it like that. But hopefully you see pretty quickly that it's not going to work, right? We can't multiply something to be -4 and add it to be 2. Okay? So what other way do we know to solve quadratics? Quadratic formula. Okay? X equals -b plus or minus the square root b squared minus 4ac all over 2a. Sir, what did I do this time? B squared? 2 squared? 4? It's okay. No, it's okay. I just did it in my head. I'm sorry. I skipped a step. So -2 plus or minus the square root of 4 plus 16 over 8. So -2 plus or minus the square root of 20 over 8. Now I don't know the square root of 20, but I know that 20 is 4 times 5, and I do know the square root of 4. So I've got -2 plus or minus 2 root 5 over 8. And then I know that all 3 of these terms right here are all divisible by 2. So I can simplify that. -1 plus or minus the root of 5 over 4. Okay? Oh, you can't even see that. All right? Now, because of the fact that we are trying to find a domain, this number doesn't really make sense as a domain number, like an x value. It makes sense if I say solve this quadratic, that is the right answer, but it's not really a tangible number for us, so we really need to figure out what number that is. Okay? So I'm going to go to a calculator page and I'm going to say, give myself a fraction, -1 plus the square root of 5 over 4, which gives me approximately 0.309, and then minus, same thing as except minus, -1 minus the square root of 5 over 4, which gives me approximately -0.809. Okay, that's where I need to go to figure out what my my boundary points are. We didn't really talk about that here because we just kind of went on with it, but these are kind of my boundary points, aren't they? It's like where something stops and where something starts. This part down here is not counting. The part up here is counting, and the 2 and the 5 were my boundary points. Well, these are my 2 boundary points. Okay? It would be nice if I knew what this looked like, so I'm going to go graph it. 4x squared plus 2x minus 1. And that's what it looks like. Okay? So if I graph it just for myself, it's going to look something like that. Close, right? Now I want everything here that's less than or equal to 0. So what part am I looking at this time? I'm looking at this part this time. That's the part that I want to talk about as my solution, right? So it's going to be everything between those 2 points. Well, this point I know from my solving earlier is .809, and I know this point from my solving earlier is 0.309. Now, I know this is not a very accurate graph. I didn't draw it for its accuracy. I drew it for my vision to see what it looks like. Okay? So where is my solution here? It goes from -8.9. Oh, why do I keep doing that? 0.809 is less than x is less than 309. So that's inequality notation. In interval notation, it would just be -0.809 to 309. Except I did mess up. Can you tell me where I messed up this time? What kind of sign was in the beginning? Equal to. So this one should also be equal to, as should this one. And then these should be brackets. So I did that on accident. I totally didn't do it on purpose, but I want you to see how easy it is to mess up stuff like that. Okay? We fixed it. We figured it out, so it's okay. But just think about that as you're doing the problem. Go through like normal. Before you start writing your answer, look back at your original question. What kind of sign was there? Okay? We had to look at the sign to know first of all, if it was above the line or below the line of 0. And then use that sign also to know if these are less than or equal or just less than, and to know if these are parentheses or brackets. Does that make sense? So that's solving polynomial inequalities. To solve rational inequalities, you're doing the same kind of thing. Whoa. Except if we have 3x plus 3 over 2x plus 4 is greater than 0, what we have to figure out is, what is the domain? Okay? We did talk about that a little bit when we were just visiting before class started. The domain, right? To find the domain of a rational function, we take the denominator and set it equal to 0. Seriously. 2x equals negative 4, so x equals negative 2. Okay? If the domain is not equal to negative 2, my domain would look like this. Negative infinity to negative 2, and then to get on negative 2 to positive infinity. Or we could write all real numbers except negative 2. All right? That helps us with just trying to figure out what the answer is, right? Our function is not defined at negative 2. Okay? So let's look real quick at what the graph looks like. Give myself a fraction. 3x plus 3 over 2x plus 4. So I know that there's an asymptote right here at negative 2, because I know that that's where my function is not defined. So I have to figure out, where is that greater than 0? Where is this function right here greater than 0? Well, if 0 is right here, we're talking about the stuff above it, right? And then we've got our asymptote right here at negative 2. And then we come up like that, right? So what does that mean as far as the solution goes? Well, where's my solution? Here and here, right? So how do we write that? We write everything from negative infinity to negative 2. That can't be part of my answer because it's an asymptote, right? But then where does it start? Right there. Where is that? Well, again, I can use my calculator skills, can't I? Okay. I can use my calculator skills to figure out where that is. And, well, how do you want to do it? Like a 0 or an intercept or what? 6, 1. A 0. So I want a 0 right here. Oh, that's nice. It's a negative 1. So again, at negative 1 to positive infinity. Now I know these are right here for the record. Okay? Because it's just greater than. Any questions? What if the problem said 3x plus 3 over 2x plus 4 is less than 0. Would I have to do any more work? Way less, right? If this work is, especially if this work is already here, right? I know that this is the only part of my solution right here for this particular problem because it's the only part of the graph that's less than 0. Well, I know it gets all the way to -2 but never touches it, so -2, and then where does it stop? Right at -1. Okay? So two different views of the same problem. I just wanted you to make sure you understand where the solution is based on the inequality sign, whether it's above the axis or below the axis. That's why it's so important for us to get it equal to 0 or get it inequality sign to 0. Okay? Because we have that very specific dividing line right there. Okay? Does that make sense? How to do both of those, the polynomial and the rational? Okay. Just to make sure. Now, we didn't do any word problems, but those are pretty straightforward. Read through the problem. A lot of times on the problems, it'll give you the inequality to use, excuse me, the problem, either the polynomial or the rational function to use, and just solve it like we just did these ones right here. Okay?